Hello everybody. In this video, we are going to learn about deep learning, and in the part of deep learning, we are going to see introduction to machine learning algorithms, which is a part for deep learning. Now, what is machine learning? Machine learning is basically a branch of AI which focuses mainly on the development of systems where the systems can learn from the data itself without being explicitly programmed for that. Now, this allows various computers to identify certain patterns in the given data and make predictions upon it along with its improvement in performance over the time. Next is some techniques used in machine learning, namely supervised, unsupervised, and reinforcement learnings. Now, learning about supervised, these are algorithms which are from labeled data, meaning the inputs are paired with the corresponding outputs, and the goal of it is to learn a mapping from inputs to its outputs, meaning the data here is already like more or less segregated and like you have given labels to it. Now next is unsupervised learning. Now these algorithms are unlabeled data and they are used for identifying patterns and structures without being predefined outputs. Now, these are very helpful in terms of clustering and reduction in dimensity. Next is reinforced learning. Here, the algorithms learn through trial and error methods, just like humans, and they interact with a given environment, and they receive rewards when a particular thing is done right. Now, the goal here is to learn through an optimal policy to maximize the accumulative rewards. Very similar to the humankind, where the humans, especially in terms of like short reward span, it works in such way. Next, we'll learn in detail about supervised learning algorithms. Sorry, it's supervised learning techniques, in which there are four learning algorithms. Now here, first one being the linear regression, very helpful in maths. Now these predicts a continuous input variable based on a linear relationship with the input variables, meaning the value inputs are continuous or correlate. Next is logistic regression. This predicts a categorical input variable such as 0 or 1 using a logistic function. The next becoming the support vector machines, also called as SVMs. These find an optimal hyperplane to separate data points into various classes. Mainly the work of it is to make categories. Next one is Naive Bayes. It is a probabilistic classifier which is based on the Bayes theorem with a strong independent assumptions between the features. Now here is a flowchart of how it works. Next one, we learn about unsupervised techniques, in which we are going to learn about unsupervised algorithms. Here we have mainly three most used of them. First one is K clustering. Now these work as partitioning the data into K clusters based on the distance of their centroids. Now next is hierarchical clustering. Here the hierarchy of clusters is built either bottom up or top down methods. Next one is principle of component analysis. Here it reduces the dimensionality of data by identifying the very important components which capture the most variance. Next one, we learn about regression algorithms. Here the first one is again linear regression. Now here's the graph of how a linear regression of line looks like. Now it is a model which has a linear relationship with its variables. Next one is polynomial regression. It is a model having non-linear relationship with polynomial functions respectively. Next one is ridge regression, which addresses the multi-collinearity by adding a penalty term to the loss function. In the case the loss function has some errors, there will be penalty to it, which will then be added into the error part. Next is lasso regression, performs feature selection by shrinking coefficients of less important functions to more important functions. Next one, we'll see how these ML algorithms are classified. The first one is logistic regression, which is a very simple and a very efficient algorithm for binary classification. Next one is the one we learned called support vector machines. Now these are very effective in high demanding spaces, which can be modeled for non-linear relationships as well. Next one being the decision trees. These are very easy to interpret and visualize, but can be prone to overfitting, meaning data can be overfitted into the graph itself, which can make it very complex. And finally, we have the random forest. Now, this is a method which combines multiple decision trees itself to improve its accuracy along with robustness. Now, we'll learn more about decision trees and random forest itself. Talking about decision trees, these are a tree-like model where each internal node represents the test on an attribute. Now, as such, the figure represents it. We have a branched way of representing a decision tree. Now, each branch here represents the outcome of the test, and each leaf or a leaf node represents its class label. Now, random forest, very much similar to the decision trees, is an in-assembly learning method which operates by constructing various decision trees at training time and outputs its classes at the mode of classes or classification, and also the mean prediction, also called as regression. Now this is how it showcases our random forest. Now the thing you have to note is the first main tree is your parent tree, whereas the other leaf nodes or the other branched out elements are known as your leaf nodes or child nodes. Next we have clustering algorithms. Now first we have k-means. Here it partitions n observations into k number of clusters, in which each observation of it is belonging to the cluster with the nearest mean to it. Whereas in terms of hierarchical clustering, it builds a hierarchy of clusters. And in terms of hierarchy, you know the ranking methods in various, let's say, algorithms. So the way how it ranks is very much the name called as hierarchical here. So it starts with each point with a separate cluster itself, and it then merges into the closest cluster to it, and it then later starts with a single cluster, then it recursively splits it into two. And the last one is TB scan. Here it groups together points which are very closely packed together, and it marks its outliners to lie alone in low density regions, meaning when the density or the number of clusters at a given area is low, it is very helpful in those manners. Now next we have neural networks and deep learning. Here we have certain techniques, or let's say we have several methods here to learn. First one is perceptron. It is a fundamental building block of neural networks, or also called as single layer neural networks. Next one we have multi-layer perceptron. It is a feed forward neural network with multiple layers which is capable of having complex patterns as well. Now the part feed forward here meaning the output of a single node or an algorithm isn't taken as in the input part. Next one is convolutional neural networks, also known as CNNs. These are specialized for processing of image data only. Text is RNNs, which is designed for sequenced data such as text and time series. And that's it for this video, people. I hope you liked it, and you can give your thoughts in the comment section below. Thank you for listening.